Today's presentation is the first in our Critical Manufacturing Processes series presented in collaboration with MedAccred. This one is on printed circuit boards and printed circuit board assemblies. I'm Courtney Stevens, an attorney in our Loss Control Department at Medmarc. On behalf of Medmarc and today's presenters, Julia Markardt and Michael Brown, thank you for joining us. Julia Markardt is a staff engineer at the Performance Research Institute, responsible for performing critical process audits on various electronic processes and components. She has 40 years of experience in the electronics industry, including extensive experience with NASA and U.S. military projects. She brings exceptional subject matter expertise to this topic. Michael Brown began his career with Celestica at their headquarters in Toronto, Ontario. Roles included PCBA mechanical test engineer, vibration, thermal, and shock environments, and advanced process development engineer for new processes, fine pitch, lead-free, PCBA, stress strain analysis. He joined Stryker as a supplier quality engineer with Stryker Electronics, in-house PCBA manufacturer, and is now a staff audit supplier quality engineer with a focus on PCBA supplier auditing and development. He is based in Redondo Beach, California. With that, I am pleased to turn things over to Julia, who will begin today's presentation.
Thank you, everyone. The agenda for today's topic, Michael and I were asked to address the critical manufacturing processes that are used in electronic manufacturing. We'll give you a few examples of product failures, and we'll stress the importance of technical standards and compliance. I'll also give you some insight into the top nonconformances that we found in the past year of conducting MedAccred accreditation audits, and also some typical initial root cause responses that we've received. We're also going to show you the critical process elements of printed board assemblies and also printed boards, and then explain what the medical device industry is doing to improve PBA and PB quality and supply chain oversight. This photograph was actually taken during one of our audits, as was the previous photograph. I'm actually standing in the background. It's a process audit that we do for MedAccred, and I'd like to begin my audits usually by asking the operators to simply show me what you do. And you can see there the operator is showing the auditor. It's taking her through the work process and showing a little bit about what she's doing. Throughout the presentation today, I'll be mentioning some critical manufacturing processes, also the best practices for ensuring quality, consistency, safety, and also reliability. So keep that in mind as we go through this program. On the screen right now are a couple of products that were recalled by the FDA. If you take a look, the first product there, BioConsole extracorporeal blood pumping console, the reason that it was recalled was the motor controller printed circuit board had a capacitor that was installed in reverse. So in looking at this, the first thing I'm asking myself is, why didn't the test catch this? Also looking at this without really knowing what the outcome was, it indicates to me that the customer specification's not really being followed correctly. Perhaps there's a lack of training, inspection, lack of testing. Clearly an IPC violation, a technical standards violation. Verification of manufacturing processes would ensure customer specifications are being correctly interpreted, and the training and inspection processes are robust. Mike, you have something to add?
Yeah, and I would add here that, it's important to remember that in medical device manufacturing, we have a lot of things above and beyond IPC requirements, and that's one of the things that MedAccred does, is ensures beyond IPC that, we're checking that customer specifications are met and the issues that may not be caught with general IPC.
The next failure we have on the screen is a circuit board failure also. It's a ventilator, and it's a failure of the CPU circuit board. And this could result in a blank display or loss of mechanical ventilation. That could be attributed to many different causes, improper handling of moisture-sensitive devices. It may be a counterfeit component. It could be a design or a bare board defect. Any of the nonconformances that we'll be discussing today could lead to a product failure. Mike?
Another good point to mention is, standard rework per IPC and non-standard rework, which, is very important in medical device manufacturing because it could affect the validated state. So all of those things are really important to look into, as well as obviously unapproved changes that may affect the product and cause recalls.
Okay, on the next slide, here's a partial list of the standards that we use for electronics manufacturing. I spoke earlier about violating the IPC standards, and it seems like, this is what we find. A lot of the nonconformances that we're finding are just, they should have complied with the standard. If they would have complied with the standard, they would have been in compliance. And so you'll see here we have our typical printed board technical standards, the IPC 6010 series, the 6012, 13, and so on. We have the IPC A600, which is the acceptability of printed boards. And then for our assemblies, it's typical to see the IPC A610, the J Standard 001, as well as the J Standard 002 through the 033. We also have the IPC 77, 11, and 21 for rework, and we actually don't cover repair, but we do cover rework. And then there's the IPC TM 650 for your test methods manuals. And in addition, we do require a QMS certification. It can be ISO 13485, ISO 9001, etc. And also in our audit criteria, we take into consideration that the FDA's 21 CFR Part 820, both the device master and the history records. And Mike?
Yeah, and I think this is a good time to mention as well how the medical industry and the PCBA industry kind of differ. In electronic devices, it's constantly changing, they're constantly updating, and in medical devices, we're really trying to limit that change, and that's really part of the 21 CFR device master record and device history record. We're really trying to limit those changes. So that's really the thing we struggle with high level on an ongoing basis, is making sure that devices are produced in a similar, consistent way.
And one other thing I want you to notice, I mentioned the J Standard 001, and notice the J Standard 033. This is one of the most misunderstood technical standards in PBA manufacturing. The requirements in the 033 include moisture barrier bags that meet the MIL PRF 81705 Type 1, desiccant material that also has to meet a specific MIL type. Humidity indicator cards have to have 3 color spots. And we often see companies not properly logging time out of the bag or adding the times out, not adding the times correctly, and with regards to requirements for baking. So that's, I think, one of the things that we hope to accomplish today is just to give you a little bit of direction as to what maybe the industry needs to take a look at with regards to more education. Okay, on this next slide, I mentioned earlier about the best practices for ensuring quality, consistency, safety, and reliability. And here's a list of some examples of what can happen when we do not comply, like product quality. If the solder purity, which is a J standard requirement, if your solder is contaminated, contaminated solder can cause poor electrical connections. It can cause solder joint failures and degradation. Hand soldering techniques and certification. Sometimes we find people reheating solder joints over and over and over again and not following the J standard. And even the wrong technique can cause solder joint failure and degradation. With consistency, we've put process validation into our checklist, and that's become very important in the medical industry. And I know, Mike, you had something to say about that.
Yeah, and we make the joke when we're doing these reviews at suppliers, that don't make the product better, make it the same, and that really speaks to process validation. You see a lot of changes made by suppliers with the intent of making things better. It could be a change of technology, it could be something like that, and that's a huge source of nonconformances due to unintended consequences. An example could be in PCBA, changing out a mechanical drill for a laser drill, thinking that, the tolerances are better and my customer will be happy. But in medical devices, that could have a knock-on effect to the validated state of the product. So it's a huge issue.
And then we also, with process validation, we're looking for that validation protocol, and that includes your IQ, OQ, PQ that you hear in the medical device industry for installation qualification, operational, and also performance qualification. We also use time temperature profiles. Those are developed to ensure the optimum solder quality. And factors that affect time temperature profiles are room temperature and humidity. Often we find that companies are not monitoring the room temperature and humidity, things that could affect that critical time temperature profile. Part of the time temperature profile are conveyor speed and oven temperature. Also, solder paste quality plays a large part, so refrigeration, time out of refrigeration, solder paste viscosity, rheology, thixotrophy, all of those are very, very important. With regards to through-hole, we have recipes for our wave solders. They're kind of like a time temperature profile. They're also developed to ensure optimum solder quality. Another thing that we look at, and we found, sometimes there's a little bit of a lack of detailed work instructions. Are the operators following the work instruction? That's what we look for first. Do they understand it? Did you error-proof that process? Did anybody walk through that work instruction with the operator to make sure that they can understand it, that they can follow it? Sometimes we find errors in the work instructions themselves. Also, does the work instruction comply with the technical standard? Does it call out for the inspection criteria? If an operator is inspecting their own work, they need to know what to inspect it to. Is it IPCA 610, Class 2, Class 3, J Standard, Class 2, Class 3, and so on. If I ask an inspector what their inspection criteria is, what they're looking for, they should be able to give me those specifics. And Mike?
And especially important in medical devices is recognizing that, we produce a lot of low volume product. And because of that, we have a lot of manual processes that require specific work instructions and require very kind of manual operations that do have some variability in them. So as much as we can improve those work instructions and have them followed is definitely beneficial. Another
thing that if you comply with your technical standard, your soldering iron tip temperature should be in compliance. And going back to the process validation, it's knowing the capability of the soldering iron and choosing the correct tool. We see soldering irons that do not have the capability of holding the temperature within the specified range called out by the J standard. So that's another important step. Okay, on this next slide, we talk about safety, and electrical testing is one concern, and this is an area where actually most individuals are very highly trained, but the correct testing has to be selected. I remember hearing a story about a baby heart defibrillator that failed in the field due to an unsoldered wire, and I think it was just not soldered. So when the unit started to vibrate, it did not make an electrical contact. And I think to myself, would environmental testing, more stringent testing, would that have caught something like that, Mike?
And you see this as well, and I see this a lot at suppliers, is kind of the test it till it passes issues, where you may have a test fixture that's poor or a test protocol that's poor, and the way that they solve that is just to continue to test it, until it passes. So it's really watching those processes and those instructions and making sure that things are being tested properly. And
with regards to reliability, We have the J Standard 001 or the IPCA 610 or the 600 Class 2 or Class 3 products. What thought has been given in selecting the appropriate class? Sometimes people say, well, I'll just select Class 2 and hope that they deliver Class 3. So, that's an important consideration. Also, does the operator and the inspector know the class? If Class 2 is selected when a product will be subjected to movement or environmental stresses, or if a person's life is at stake, the wrong class clearly has been chosen. Environmental testing can lead to reliability, heating, cooling, vibration. Will the product last in its intended environment? Material management, I always stress, read the technical data sheet. So many times we'll see adhesives or potting materials that are mixed, applied, and cured not to the manufacturer's specifications. And that's fine if that material's been qualified, but when the default is the manufacturer's specifications and that specification is nowhere to be found, then I make them go and get it. I check it to make sure that they're in compliance, and oftentimes they are not. Either the oven temperature is off, or the time in the oven is not correct, or it's not recorded. So if it's not recorded and the operator's distracted, they have no idea of how long a product's been baked. We need to log this in, and we need to log the in and out times as part of our history record. Also, there's a lot to be said lately about cleanliness testing. Too many times we hear, well, it's a no clean flux, therefore we don't have to be concerned. Then I noticed operators pouring companion flux from a squirt bottle. Our local chapter of the SMTA just had a seminar on cleaning, and it was a real eye-opener. The amount of dendritic growth from flux contamination is astounding. And by the way, a sticky or tacky substance on an assembly is a defect according to the technical standard. And we're often we wonder how long will a solder joint last. And I was once told that a good solder joint would last 30 years, but that was back in the days of tin and lead. And we use a lot of lead-free in the medical industry. So today's solder joints depend on many more factors. I think Kester said it best in one of their papers that reliability with lead-free soldering can only be achieved if all the variables are carefully considered. And this begins with components and boards, followed by alloy and flux selection, and finally the thermal optimization of the soldering processes. So again, it's complying with the J Standard 002 for solderability, the 003 for solderability of the printed board, 004 for flux, 005 for solder paste, and then the J Standard 006 for solder. Then it's complying with the J Standard 001 for time, temperature profile, solder, joint quality, etc. Mike?
And especially now that we live in a world of, lead-free, and we're operating much closer to the boundaries of the materials, that, the use of generic oven profiles on products where you may have multiple products running a similar oven profile, and people forget to change the profile when a new product is put down the line, or they're using a generic oven profile outside of where they should be using it.
Okay, these are the top nonconformances that we found, and the reason why I've chosen some of these earlier examples that we already spoke of. Solder purity is one of the top nonconformances. We're finding some contaminated solder, and I know that also, the IPC industry is looking at this as well. The J Standard group is looking at the possibility of maybe even changing the nickel content in the near future. Also, environmental controls, not monitoring or controlling temperature and humidity. So, again, what happens to our time temperature profile if the building is too hot, or the building is too cold, or, we have some ESD issues. And electrostatic discharge issues can lead to latent failures. Those are things that fail in the field. We don't always find those during test. So when the humidity drops below 30%, we need to take additional ESD precautions. And with components becoming more sensitive, the chances of damage from ESD increases. And I know the NADCAP group, the aerospace group, is looking into having their suppliers do more stringent testing when an ESD violation has occurred. Mike?
This is a huge issue that I see all the time at suppliers. It's kind of like, everyone says they wash their hands after they go to the washroom, but the data doesn't support it. ESD is exactly that. On the surface it looks like everything's okay, but when you dig into the details, you find multiple ESD violations. And because of the latent failures versus failures caught at test, it's not something where there's a feedback loop to improve it. So it's a huge issue.
Another top nonconformance, and I talked about that earlier, is moisture control, the J standard 033. Moisture turns to steam in an oven and it expands and it damages components. We see so many violations with regards to just recording the time in and out of the moisture barrier bag, the wrong type of bag, a bag that leaks, humidity indicator cards not correct, and so on. Mike?
And there's really a general lack of, of active management of moisture sensitivity. You see people saying, we never have it out of the oven long enough that it really matters until there's a disruption in production and everything sits out for a couple of days and then nobody thinks about it. So, you really want to see an active management of that, recording the times, making sure that you're not going over the limit, stuff like that. So.
We also have seen issues with cleanliness. We know that dendritic growth is a problem, and we'll talk a little bit more about flux residue. Also, we've seen violations of foreign object debris and damage, FOD, that can transfer to the product. It affects solderability. Lead clippings can cause a short. Flux residue can cause dendritic growth. It can also be flammable. And, flux residue, I remember one time a company said, we don't need to remove the flux from a board. And they were building some light signal systems for doctors' offices, and when they brought it, when their system failed and they brought it back in from the field, this was a printed circuit board that went into a wall of a doctor's office, and just the vibration from people walking around in the office and it being inside the wall and all the drywall dust, the printed circuit board looked like it was wearing a fur coat. So it caused it to short out prematurely. So flux residue really is an issue. Also, shelf life, work and pot life are top nonconformances. Topping off the flux container in the wave solder machine, at what point is that flux out of shelf life? How do you know how long that original flux has been in there? What is the shelf life of the original flux? When a product is mixed, the time should be recorded and the work life should be known. We see so many times when they say, well, when it starts to get a little bit too hard, then I stop using the adhesive. But that's not good enough. We see a lot of operators that do not know, and why should they know if it's not written in their work process? So, that work and pot life, they need to know that. Also, hardness testing is not always required. So sometimes we're just, relying on them following the pot life. We also see issues with gold embrittlement, and that can cause degradation of your electrical connection, and again, not conforming to the J standard with regards to degolding components and gold cups. Also, one of my pet peeves, my personal pet peeves, is not recording rework. Excessive rework can lead to solder joint failure. It's also a fraudulent device history record. A lab can tell by the thickness of the intermetallic bond if a solder joint was heated repeatedly. Mike?
And on top of that, in some cases, we have restricted rework for specific devices because of it affecting the product quality. And in many cases, if they're not thinking about recording IPC rework, they're certainly not thinking about recording or thinking about whether or not the customer has to approve rework.
And also we see issues with solderability, trying to overcome an unsolderable part. That results in, again, excessive reheating, excessive rework. First in, first out rules need to be adhered to, as well as the J Standard 002 for testing for solderability. On this next slide, we have some typical initial root cause responses. One of them, the engineer did not read or fully understand the technical standard. Why did the engineer not read or understand? And the example, the NCR was written against the moisture barrier bag, the desiccant material humidity indicator card, and the operator did not know how to read the indicator card. So why did the engineer not read or fully understand? Mike?
And this, again, dovetails really well in with understanding the specific customer requirements that there may be above and beyond IPC.
Another typical initial root cause response was the engineer wasn't aware that solder touch-up was needed or needed to be recorded. Well, why was the engineer not aware of that? That is a J standard requirement. And I've listed it below in 13.1, hardware defects shall be shall be documented before rework or recorded. Rework for Class 2 should, and for Class 3 shall be documented. The second application of a soldering iron during a hand soldering operation of a single connection is not considered rework. So you get to reheat it one time if you're hand soldering. The third time is rework. The second time after surface mount ovens or wave soldering or select soldering, that is all considered rework. Mike?
And that's just really a good general flow down of what the FDA calls good documentation practices, and making sure that everything is recorded. And for companies and CMs that are only maybe doing 10 or 15% medical and the rest is commercial, really flowing down those specific to medical requirements to make sure that everything is documented effectively.
Okay, on this next slide, I'm just giving you the critical manufacturing processes for printed circuit board assemblies, and you can see them listed there. Process validation is one that is in our audit criteria across the board for all of our MedAccred commodities. Medical record keeping is included in our audits. FOD, foreign object debris and electrostatic discharge, calibration, preventative maintenance, facility environmental management, purchasing and authentic component assurance, process control, CAD/CAM data, receipt, inspection, and control of incoming material, storage and handling of received materials and component programming, electronic component preparation, stencil printing, component placement, in-process placement, verification and inspection, assembly, soldering and processes, secondary assembly, PCBA, cleaning process and control, coating and encapsulation, adhesive bonding, assembly testing, final acceptance inspection, rework, and storage and handling of packaging of finished goods. These are all critical process elements. Mike?
And this is where, being an OEM who, we audit multiple suppliers, and we really just have the time to do a quality management system audit and a little bit of a process audit. This is where MedAccred does a really, really deep dive into each individual process, whereas the OEMs don't have the time or the resources to do that. So it really does complement each other well.
Okay, we're going to take a look at a couple of those critical process elements and two additional items that are very critical today, purchasing an authentic component assurance and receipt inspection and control of incoming materials. We always hear we don't buy from brokers. We only buy through vendors that our customers approve of. And what if they're brokers? You still need to have procedures in place to stop counterfeit material from getting past receiving inspection. Mike?
And purchasing controls, supply chain management, these are really the most critical success factors going forward for the OEM-CM relationship, and the FDA has certainly made that clear to the OEMs. And I think going forward, and it's something that we focus on very closely, purchasing controls really is one of the most important elements of success.
Okay, on this next slide, we have our PB manufacturing critical process elements, and I won't go over all of these, but you can see, and they're in your presentation. There's one slide here, and then we have another slide. So this is all for printed boards, and this audit criteria will be out next year for companies to become accredited. And Mike, would you like to add to this?
Just adding to the fact that, in a world of, increased outsourcing and much less vertical integration, MedAccred, gives us confidence that, the critical processes done further up the supply chain, can produce consistent quality products.
Okay, and what is the medical device industry going to doing to improve PBA and PB quality and supply chain oversight? Well, the first thing we have are our electronics PBA and PB task group. It's made up of OEMs such as Stryker, Philips, J&J, GE Healthcare, also suppliers, Flextronics, Kimball, Sanmina, and Eltec. Our task group is open to subject matter experts from OEMs, contract manufacturers, and suppliers. We work very hard to develop audit criteria and also to approve subject matter expert auditors and to grant supplier accreditations. The MedAccred accreditation is used by OEMs and contract manufacturers as a criteria to award new business and oversee their critical process supply chain quality. Mike?
And just, in terms of calibrating it with the QMS type audits that an OEM would do, we've seen some good alignment between what the MedAccred audits find and what we find in a quality management system audit. That being said, MedAccred has the ability to dive much deeper and get further into the issue.
And suppliers can use the MedAccred accreditation to ensure final product quality and also to improve manufacturing operations. All right, are there any questions?
Yes, we have some questions.
We'll now begin the Q&A session. If you have a question, please feel free to submit it using the Q&A panel located at the bottom right of your screen. After typing your questions in the space at the bottom, hit the send button. Please be sure to direct your questions to all panelists in the Ask menu. Your questions will not be seen by other members of the audience. Julia, can you give me some examples of what you'd be looking for in a process audit versus what most medical device manufacturers are familiar with in a quality system audit?
Yes, a quality system audit looks at a company's document structure. A process audit examines the actual manufacturing processes such as hand soldering, machine operation and maintenance, witnessing, adherence to work instructions, and so on.
Okay, great. We have a question. As a contract manufacturer, what will I gain from achieving a critical process accreditation?
As a contract manufacturer, while many of the OEMs either mandate or will be mandating the accreditation, the benefits far reach satisfying just that mandate. Our suppliers feel that having gone through the process has helped them to better understand their role and responsibilities as manufacturers. It's also helped them to improve their own processes.
Great. Maybe, Michael, could you answer for, as an OEM, what
Sure.
there is? Yeah, thanks.
Sure, yeah. So the first benefit I think you're going to see is improved quality. I think, if you look at the NADCAP program, you've seen that over the past number of years. Second to that, and this is a little bit down the road, but I think you're going to see fewer supplier audits. If MedAccred is doing an audit, in the future, we should be able to accept that as an audit. in-house as well and not have to do a visit, so you should see fewer customers. And then, down the road, obviously, business is going to be leaning more towards MedAccred accredited organizations.
Great, thanks. And looks like we've just got one more question here, and this person wants to know how they would schedule an audit.
A supplier can schedule an audit by going on our website, www.eauditnet.org, and first registering and then following the prompts to schedule an audit. Or they can contact myself or Justin McCabe or Connie Conboy here at PRI, and we'll make sure that we put them in touch with our eAuditNet support group.
Oops, okay, thank you. We've got one more question that came in here. Julie, I'm guessing this, well, probably either of you could answer this, but which, if any, standards apply to the manufacture of products powered by batteries?
Michael, can you answer that one?
I'm trying to think of what would be different with products powered by batteries. I will state that I'm a mechanical engineer, so maybe, but from the electrical side, so I don't want to speak out of tune here, but I would say there's really, all of the standards are applicable, all of the IPC standards, specifically for batteries themselves, and maybe they're asking about lithium ion and things like that. I wouldn't have any experience with that.
Okay.
Now, let me add one thing to that. I have heard there has been some talk here at PRI about a task group, just for batteries. So, as we gather more information from the industry, we'll make that available.
Great, yeah, that would be wonderful. We'll keep, all of our constituents at Medmarc aware of developments at PRI and the different task groups. So that's great. And I think that will do it. Looks like we've got through all the questions. Thank you so much, Julie and Michael. I know this is really invaluable information to those manufacturers, OEMs, and suppliers either making or sourcing PCBs and PCBAs. So thank you so much.